Okay, completing the square. So we've looked at factoring quadratics and being able to find the zeros. We've looked at solving a quadratic by simply finding the square root, finding the roots of it. What if you can't factor it and there are two terms? There's a squared term and a non-squared term. So I can't factor. I can't solve with the roots. Is there another option? Yes, there's another option called completing the square. So when we looked at the beginning, when we were even looking at factoring, there were some special things that we looked at. We looked at the difference of squares, which means the first term was squared, the second term was squared, and there was a subtraction sign in the middle. We knew that that would always turn out to be our x terms, and then our second term. So in this case, that would be 5. One would be positive and one would be negative. We knew how to factor that. Okay. We also looked at perfect square trinomials, which meant that both of our binomials were exactly the same. When they were exactly the same, we could write them together with an exponent. Well, that ties directly back into being able to find the root, because now I have a singular variable with an exponent of 1, and my whole thing is squared. Okay, so then we ask a question. If we can't factor, if we can't take the root, can we make it factor by turning it into a perfect square trinomial? And the answer to that is yes, we can. So let's look at this one. We've got x squared plus 10x minus 3 equals 0. Can I factor it? Well, to factor, I have to ask myself, are there any two terms that multiplied together give me 3 and subtract to give me 10? Well, no, because the only terms of 3 are 1 and 3. And there's no way that I can take 1 and 3 and subtract them and get 10. So no, I can't factor it. I can't just take the square root because I already have two variable families here. I have a squared term and a regular term for that. So that doesn't work either. So we are going to make this factor. To make it factor, we remove our constant. We move it to the other side. Remember, we are setting our equations equal to 0 because we are looking for the place where the graph crosses at y equals 0. So we set our equation to 0. We have moved the 3 over to the other side. I added it to both sides, and now I have a blank space. What should I put in the blank space? Well, the question that we are asking when we wanted to find that perfect square trinomial are what two terms or what terms multiply together to equal this number and add to equal our middle number. Well, if I want them to be exactly the same because I want them squared, then I have to change that question of what two exactly the same terms multiply together to give me something and add together to be 10. So what two terms that are exactly the same add up to be 10? The answer is 5. 5 plus 5 together gives me 10. So if I were looking at my perfect square trinomial and I had it laid out, I know to get my center value of 10, I have to have the exact same for my outer and my inner. So if I have 5x and 5x, I get 10x. So what does that do for this third term? Well, my third term is of FOIL, always comes from the last multiplied together. So 5 times 5 gives me 25. So I can put a 25 there. Now the rule for math is whatever I do to one side, I have to do to the other side. So if I put a 25 on my left side, I have to put a 25 on my right side. So now we have x squared plus 10x plus 25 equals 3 plus 25. Let's simplify what we can. Well, I made the top part factor into a perfect square trinomial, so I can rewrite it as x plus 5 as that binomial squared. Now I have 25 plus 3 equals 28. Well, we're back to going, I want to get x by himself. How does he go to the movies by himself? The problem is I have a squared term. The opposite of squaring is to take the root. So we'll take the square root of both sides. When I take the square root of the left side, I need to, I have to, I'm simply left with my base. So I have my entire base left over. On the right side, I just took the square root of a number that wasn't squared in the first place. So I need to have a plus or minus value there. I can break 28 up into 7 times 2 times 2. I need to, I have to. Here's my set of 2. It escapes. I could also break 28 up into square root of 7 times the square root of 4. I know that the square root of 4 is 2. So we have 2 square roots of 7, but we have a plus or minus there. Okay. So now again, I'm back. I've got x plus 5 on one side. I've got plus or minus 2 square roots of 7 on the right side. I want to get x by itself. So I'm going to do the opposite of 5. Subtract 5 from both sides. Now remember, this 5 is in an integer family. This 2 square roots of 7 is in a root family. They cannot be merged all together. So we are going to write it as -5 plus or minus 2 square roots of 7. That could also be written -5 plus 2 square roots of 7 and -5 minus 2 square roots of 7. Okay, so here's another example. For this one, in this case, the very first thing that I see as a problem is that I've got a coefficient on that x squared term. And remember, we always want the x squared term to have the coefficient of the number 1. So we're going to try to get rid of it at all costs. In this case, to get rid of it, I can divide the entire equation by 3, which in effect is taking the entire equation and multiplying it times 1/3. So this gets distributed to every single term. So I'm left with x squared minus 2x plus 4, and 1/3 times 0 is still 0 in that case. So then I ask myself again, are there any 2 factors of 4 that I can add together to be 2? Well, with 4, I only have 1 and 4 and 2 and 2. And 1 plus 4 is 5. 2 plus 2 is 4. So no, I cannot factor this. So let's make it factor. We will remove our constant and we're going to move it over. When we move our 4 over, we're going to have a -4 in that case. And then we get left with our blank space here. Okay. So then I ask myself, what do I want to put in the blank space? Well, I need 2 of the exact same numbers that add up to be -2. Well, -1 plus -1 gives me -2. The shortcut for this is we take our coefficient, our b value, and we divide it by 2. So in this case, -2 divided by 2 gives me -1. So -1 will be the value that I place in my binomial that is squared. But to know what term I put there, I then have to square it. So -1 squares gives me a +1. So I add 1 to one side. I had a -4 brought down, and then I add 1 to the other side. So I now have x minus 1 as a binomial squared, and I've got -4 plus 1, which gives me a -3. Okay. So we take the square root of both sides, square root of both sides. I need to, I have to. All I'm left with is x minus 1. I'm left with that whole base underneath. And I just took the square root of a number that wasn't already squared. So I have to add a plus or minus and then say -3. Well, we don't like that -3, so we're going to say square root of 3 times the square root of -1. In this case, we know we can replace the square root of -1 with the letter I. So I have x minus 1 equals plus or minus square root of 3i. Typically, you can see it like this. Often the I will go in the front just so that you know that it's actually not underneath the radical. So we ask ourselves the same question. I want to get x by itself, so I have to add 1 to both sides, add 1 to both sides. Remember, this 1 is not in the same family as our square root. So we have x is equal to 1 plus or minus I square roots of 3. Let's see.